everybody, we're going to be looking at quadratic equations today and specifically figuring out what the roots are and then what we can do with them. So first I want to review some of the skills that we looked at last week where we learned how to multiply binomials. We're going to be doing this using the FOIL method. The FOIL method is a really efficient way for us to make sure that we are multiplying all of the terms from our first binomial. So the problem here that we're looking at is x plus 6 times x minus 4. To multiply these two binomials, I need to use the FOIL method. So the very first thing I'm going to do is multiply my first two terms. And I'm going to connect those here with a red line so that you can see. Off to the side, I'm writing that I'm multiplying x times x. Remember, x is actually x to the first, and so we can use the product rule here to combine them into x squared. Next, we need to multiply our last two terms, or our outer terms. They're the terms that are the farthest away from each other. So I'm going to multiply 4 times x, actually negative 4 times x, and that's going to give me negative 4x. Make sure that you're writing down the correct sign as you are doing these types of problems. The next thing we need to do is multiply our inner terms. So those are going to be the terms that are closest together. This time it's 6 times x, which is going to be 6x. And then finally, I'm going to do my last two terms here. I'm going to multiply 6 times negative 4, which gives me negative 24. So there we go. I've completed the acronym, and now I need to simplify. My first term can't be combined with anything else. There are no other terms that have an x squared. So I can combine my middle two terms here. I can combine negative 4x and 6x, and that's going to give me 2x. Finally, I can't combine negative 24 with any other terms, and so my final answer, my quadratic here, is going to be x squared plus 2x minus 24. Now that we've multiplied our binomials, what kind of expression do we have? What do you notice about it? I want you to take 5 seconds here to pause the video, look at that expression, and make note of your observations. You can take as long as you need. The very first thing that I notice is our answer has 3 terms instead of 2. That tells me that our answer is not a binomial expression. I also notice that my highest power is x squared. For each of our binomials, the highest power was x to the first. Let's talk about what that difference means. I want to compare the expression that we created to the definition of a quadratic equation. A quadratic equation, written in standard form, is ax squared plus bx plus c. A, b, and c are values or coefficients, and x is the variable. When x squared is the highest power, I know that I'm dealing with a quadratic equation. So turning back to our example here in blue, I can see that the highest power is x squared, so I know that I'm dealing with a quadratic. And I can also see that our answer takes the form ax squared plus bx plus c. In our case, a is 1, b is positive 2, and c is negative 24. When we multiplied the binomials together, we created a quadratic equation. The next thing I want to explore here is what a quadratic equation looks like on a graph. What kind of shape does it create? What are the key terms that we need in order to be able to talk about these graphs? Let's find out. On our screen right now, we're looking at the graph of a quadratic equation here. We're not sure what the equation is going to be yet, but we are going to find out. So let's talk about some of the key elements here. The very first thing that I notice is the shape of this parabola. It's not a line, it's not a linear equation like we're used to seeing. It's got this curved shape to it, and that shape is called a parabola. A parabola can be curved up, like this one, or curved down. The next thing I want us to pay attention to are the intercepts. The intercepts are where this parabola is going to cross that x-axis, and I'm going to mark them here and here. We call the x-intercepts of a parabola the roots, or sometimes you'll also see them called the zeros. For my quadratic here, I can see that we have zeros or roots at -1, 0 and 2, 0. Again, those are called my roots. The really big question for today is, why do our roots matter? And how can I use the roots to help me find the equation for the graph? The way I'm going to do this is by first rewriting those roots into something that we can use. I can rewrite -1, 0 as x equals -1. Because notice my x-coordinate is -1. I'm going to do the same thing for 2, 0, my other root, and I'm going to write that as x equals 2. My next step is to create a binomial expression, because we know how to multiply them, and we can use that to make the equation. Here I'm just rewriting our roots so that we have a little more space to solve. I'm going to be treating x equals -1 just like any other equation that I need to balance. I'll use inverse operations to move -1 over, so I'm going to use addition here. Once I've added 1 to both sides, I'm left with 0 and x plus 1. So if x plus 1 is equal to 0. I just found my first binomial, which is x plus 1. I need to do the exact same thing to the other side to create my second binomial. This time I am subtracting from both sides, again using inverse operations, and the binomial expression I made is x minus 2. Notice what's happening to my sign here when I express those roots as a binomial. The sign is changing. Originally I had the coordinate pairs -1, 0 and 2, 0, but when I express those roots as a binomial, I'm left with x plus 1 and x minus 2. Our third step for creating this equation to represent the graph is FOILing. So we need to take those two binomials and we need to multiply them to figure out the equation for this graph. So again, when we're FOILing, we're thinking first, outer, inner, last. So I first multiply my two x terms and I get x squared. My last two terms give me -2x. My inner terms give me x. And my last terms give me -2. When I combine like terms, I am left with x squared minus x minus 2. So now that we've done all of that work, we found our binomials and we multiplied them together, and we think we found the equation. So we're going to test it out on the Desmos graphing calculator online. I'm going to plug in our equation and we're going to see if it matches our original graph. So I'm going to go ahead and type in x squared minus x minus 2, and look at that. Our roots are exactly where we expected them to be. We can see this parabola crosses the x-axis at -1, 0 and at 2, 0. So that's just like our original graph, and we were able to create that equation just by using those roots. We are going to look at one more example that looks very close to what you're being asked to do on your Edulastic. You are going to be able to look at a graph and find those roots, rewrite the roots as a binomial, and then use those binomials to create the equation to represent that graph. The very first thing I want to do when I see this graph is identify my roots. I can see that they're at 1, 0 and 3, 0. I'm going to also then rewrite those so that I can create my binomials. I'm going to rewrite 1, 0 as x equals 1 and 3, 0 as x equals 3. Now I'm going to solve those expressions I just wrote and use inverse operations to do it. So I'm going to subtract 1 from both sides. My binomial is going to be x minus 1. Then I'm going to subtract 3 from both sides, and my binomial is going to be x minus 3. Again, notice how those signs changed. Now I need to find the actual equation, and I'm going to use the FOIL method to do it. So once I FOIL, my expression becomes x squared minus 3x minus x. When I combine that, I am left with x squared minus 4x plus 3. So there you go. We just used 3 steps to figure out the equation that represents this graph. We figured out where the roots are on the graph. We wrote those roots as binomials. And then we multiplied our binomials to create the equation or figure out what the equation actually is. So there you go, 3 steps. That's all you're going to be doing on your Edulastic this week. So make sure you follow the steps and reach out with questions. Bye!